My dear students, in my previous video, in the applications of derivatives, I have some problems in the topic indeterminate forms. Finding the limits of some given functions if the limits terminate by indeterminate forms. In this case, we have to use L'Hopital's rule and we have to apply the limits. Applying the L'Hopital's rule, we have determined the limits of the given functions. And in this video, the topic applications of first derivative, I am going to introduce monotonicity of functions. Monotonicity of functions means monotonicity, that means increasing function or decreasing function. This concept is called monotonicity. A function is increasing, a function f of x is increasing in an interval a comma b. Without using the derivative, first I am going to define. A function f of x is said to be increasing function in an interval a comma b if a less than b implies f of a less than or equal to f of b. For all x belongs to the interval a comma b. If it is the case, the function is increasing. In this interval, if you find any 2 points a and b, which is a less than b, in this interval we can find, say instead of a comma b, because interval is also a comma b, we will consider the 2 points x1 and x2. Say for example, x1 less than x2. I can say 2 points in the interval a comma b, x1 less than x2. F of x1 less than or equal to f of x2 for all x in a comma b. If it is the case, the function is said to be increasing in this interval, f of x1 less than or equal to f of x2. x1 less than x2. See, for monotonicity implies that the function less than or equal to f of x1 less than or equal to f of x2 for all x in a comma b. If it is the case, the function is increasing function in the interval a comma b. In the case of first derivative, in this interval a comma b, the derivative of the function f dash of x is greater than 0. F dash of x is greater than 0 for all x in the interval, open interval a comma b. In this case, the function is said to be increasing. It is using the derivative, and this is using the definition without differentiating the function. So in the interval, you can find out 2 different points in the interval with x1 less than x2. If f of x1 is less than f of x2, the function is said to be increasing. Or the first derivative is always positive for all x in the interval a comma. Similarly, come to the case of a decreasing function. For if x1 less than x2, in the interval x1 less than x2, f of x1 greater than or equal to f of x2. For all x belongs to the interval a comma b. In this case, the function is said to be a decreasing function. If x1 less than x2, f of x1 greater than f of x2 in the interval, we can say that the function is a decreasing function. Or in the case of first derivative, for any x in the interval a comma b, open interval a comma b, first derivative should be less than 0. If it is the case, this is decreasing function. Strictly decreasing, I mean. Less than or equal to means decreasing function. Greater than or equal to means decreasing, increasing function. Less than, strictly less than, strictly greater than means this is strictly increasing or strictly decreasing. We will see one by one. So, this is the definition for if you find 2 points in the interval a comma b, x1 less than x2, f of x1 less than or equal to f of x2, then the function is said to be increasing. Or otherwise, first derivative should be always positive for all x in the interval a comma b. In this case, f of x1 less than x2, f of x2, x1 greater than or equal to f of x2 in the interval a comma b, then the function is said to be decreasing. Or using first derivative, of first derivative of f of x, that is f dash of x should be less than or equal to 0 for all x in the interval comma b, then the function is said to be decreasing function. Okay? This is a diagram showing that increasing or decreasing. So, if x1, if the first derivative of the function f dash of x is, what is that, strictly greater than 0, then f of x is said to be for all x in the interval, for all x in the interval a comma b, then the function is said to be strictly increasing. It's not equal to 0, it's greater than or equal to 0. Instead of that, you can just write f dash of x is just greater than 0 in the interval a comma b. For all x any value in the interval a comma b. For any x in the interval a comma b, then f of x is strictly increasing. Strictly increasing in the interval a comma b. Similarly, if f dash of x is just less than 0, for any x belongs to the interval a comma b, open interval a comma b, then f of x is said to be, strictly decreasing in the interval, open interval a comma. So, by using first derivative test, we can find out the increasing and decreasing function, and we will solve by using these definitions. I am going to solve one problem. Listen. Prove that the function f of x equal to x square plus 2 is strictly increasing in the interval. The problem is prove that the function f of x equal to x square plus 2. Prove that the function f of x equal to x square plus 2 is strictly increasing in the interval, open interval 2 comma 7, and strictly decreasing in the interval, and strictly decreasing in the interval minus 2 comma 0. This is the problem. The given function f of x is x square plus 2 is strictly increasing in the interval 2 comma 7 and strictly decreasing in the open interval minus 2 comma 0. See, I am going to solve this function by using both the definitions. Taking any 2 points in the interval, I am going to take the monotonicity of the function. Similarly, first derivatives also we will see. First, by definition, say in the interval 2 comma 7, I can consider 2.3 comma 4. 3 less than 4, where 3 comma 4 belongs to the open interval 2 comma 7. So what is f of 3? F of 3 is 3 square plus 2, that is equal to 9 plus 2, 11. What is f of 4? 4 square plus 2, 16 plus 2, 18. So this is f of 3 is strictly increasing, f of 4. See, f of 3 is less than, strictly less than, f of 3 is less than f of 4. For 3 less than 4 in the interval 2, 7, I can find f of 3 less than f of 4. Therefore, by definition, f of x is strictly increasing in the interval 2, 7. By using this definition. Therefore, f of x is strictly increasing in the interval 2, 7. Similarly, by definition, by first derivative differentiating the function, we will see f of x equal to x square plus 2 is derivative of x square is 2x plus derivative is 0. Therefore, for all x belongs to the interval open interval 2, 7, f dash of x is equal to 2x. For any value of x in the interval 2, 7, this is greater than 0. Therefore, by definition of derivative test, the function f of x is strictly increasing in the interval 2, 7. Therefore, f of x is strictly increasing in the interval 2, 7. So, first condition, strictly increasing in the interval 2, 7, it can be derived in both the definitions. By definition, taking 2 points in the interval, we will consider f of x1, less than x2, then f of x1 is less than f of x2. If it is the case, f is increasing, strictly increasing. Like that, the derivative, finding the derivative of f of x, f dash of x is 2x, and derivative of 2 is 0, therefore 2x, f dash of x is 2x. For any x in the interval 2, 7, f dash of x should be positive. Therefore, f of x is strictly increasing in the interval 2, 7. Similarly, we will see the testing the monotonicity, that is decreasing value of the function in the interval minus 2, 0. By definition, we will consider 2 points in the interval minus 2, 0. I will consider 2 points. What is that? Minus 1.5 is less than minus 1. Minus 1.5 is less than minus 1, where minus 1.5, minus 1 belongs to the interval minus 2, 0. I am considering these 2 points. And f of minus 1.5, what is f of minus 1.5? By definition, f of minus 1.5 square plus 2. 1 minus 1 point square is 2.25 minus and plus 2, that is equal to 4.25. Similarly, f of minus 1 is equal to minus 1 square plus 2, that is equal to 1 plus 2, that is equal to 3. Therefore, f of minus 1.5 is greater than f of minus 1. For any x1 less than x2, f of x1 is greater than f of x2. If it is the case, f of x is strictly decreasing in the interval. Strictly decreasing. Strictly decreasing in the interval minus 2, 0. By considering 2 points in the interval, x1 less than x2, f of x1 is greater than f of x2, therefore f of x is strictly decreasing in the interval minus 2, 0. By using the first derivative, f of x, f dash of x is 2x. For any x in the interval 2, 0, f dash of x minus 2, 0. Because all the points are negative, for all x are negative x, f dash of x should be 2x, which should be less than 0, because all values are negative. X values all are negative in the interval minus 2, 0. Therefore, f of x is strictly decreasing, because f dash of x is strictly less than 0, f of x is strictly decreasing in the interval minus 2, 0. Okay, like that the function is to be tested for monotonicity increasing and decreasing in the respective intervals 2,7 and minus 2,0. That's all about the problem. Okay? Next, we will see absolute maximum and absolute minimum of a function in a given interval. Absolute maximum and absolute minimum. Absolute maximum and absolute minimum of a function in an interval. Absolute maxima or maximum, absolute maximum and absolute minimum. Absolute minimum. Absolute maximum and absolute minimum of a function in an interval. For that, find the absolute maximum and absolute minimum of the function f of x in the interval. See, how to find out absolute maximum and absolute minimum. F of x is a given function. You find out the derivative, first derivative function, f dash of x to be determined, and you have to equate it to 0. First step, find f dash of x and equate it to 0. You will get, if you equate it to 0, you will get for x1 and x2 for two values are called critical points. If you equate this f dash of x to 0, we can say 2 points x. We can, after equating f dash of x to 0, we will get two values of x, say x1 and x2. Those are called a critical point. And those critical points and the given interval, what is interval? We have to find out the absolute maximum value and absolute minimum value of the function. Critical points are the what value should be derived for x after equating f dash of x to 0. For that, you find out the problem example. Find the absolute maximum and absolute minimum values of the function. Find the absolute maximum and absolute minimum. Absolute maximum and minimum, absolute minimum. Absolute maximum and absolute minimum of a function f of x equal to 2x cube plus 3x square minus 12x in the closed interval minus 3, 2. See, closed interval, by endpoints also you have to find out the exact values. These 3, minus 3 and 2 are called stationary points. In between the intervals, we have to find out 2 points that are called critical points after equating the first derivative to 0. We have to find out the absolute maximum and minimum of the function f of x is 2x cubed plus 3x square minus 12x in the interval minus 3, 2. So what is f dash of x? 6x square plus 6x minus 12. So after taking 6 as common term, you will get x square plus x minus 2. So this is equal to 6 into x plus 2 into x minus 1. The factorization of x square plus x minus 2 is x plus 2 and x minus 1. So equating if f dash of x to 0, 6 into x plus 2 into x minus 1 equal to 0, it implies x plus 2 equal to 0 implies x equal to minus 2 and x minus 1 equal to 0 implies x equal to 1. These minus 2 and 1 are called critical points. Minus 2 and 1 are called critical points. Now we have to take out one by one. First, the n value f of 3. Substitute the value of f of minus 3 in the given function f of x. This is 2 into minus 3 cube plus 3 into minus 3 square minus 12 into minus 3. So that is equal to minus 3 cube minus 27 into 2 minus 54 plus 9, the minus 3 square 9 into 3 27 minus into minus 36. So this is equal to 36 plus 27, 63 minus 54 is 9. So f of minus 3 is 9. Similarly, f of 2, n value, 2 into 2 cube plus 3 into 2 square minus 12 into 2. So that is equal to 8 2s are 16 plus 4 3s are 12 minus 24. 28 minus 24. 16 plus 12, 28 minus 24, you will get 24. So this is one value, and for f of 2, the value is 4. And the critical points, values of f of x at the critical points, f of minus 2 equal to 3 into minus 2 cube, sorry, 2x cube. 2 into minus 2 cube plus 3 into minus 2 square minus 12 into minus 2, that is equal to minus 8 into 2 minus 16, 4 plus 3 12, minus into minus plus 24, 24 plus 12, 36 minus 16, 20. And f of 1, the critical value at f of x is at x equal to 1, you will get 2 into 1 cube plus 3 into 1 square minus 12 into 1, that is equal to 2 plus 3 minus 12, that is equal to 5. Minus 12 is minus 7. Okay. So absolute maxima is at the point x equal to minus 2 is 20, absolute minimum at the value x equal to 1 is minus 7. So absolute maximum is 20, absolute minimum is minus 7. Therefore, absolute maxima at x equal to minus 2 is equal to 20, absolute minimum at x equal to 1 is minus 7. That's all about the answer. The answer is absolute maximum and absolute minimum for the given function is so absolute maximum at x equal to minus 2 answer is absolute maxima equal to 20, because out of all the 4 values 20 is the maximum value, therefore absolute maxima is equal to 20 at x equal to minus 2. Absolute minima equal to minus 7 at x equal to 1. That's all about the answer. Absolute maximum 20 at x equal to minus 2. Absolute minimum is minus 1 at x equal to 2. That's all about the problem. And we will stop here and we will continue the remaining exercise in the next video. Thank you.